Hello, this is Kate, and this is time for paper 2, actually. This is the latest paper, 2020 November. Uh, well, I don't want to repeat the intro, so yeah, I said what I want to say in paper 1, so in case you missed that, link is in the description. So let's go, first question. Okay, so this question is obviously quite simple. So the radius 15, find that. So obviously you will find the area of the whole sector and then minus the area of the triangle. Okay, to do the area of the sector, you do half theta square, but to use this formula, theta must be in radian. So I need to find this angle in radian. To find that, I use cosine rule. So 11 squared equal to 15 squared plus 15 squared minus 2 times 15 times 15 times cosine theta. You can use the other form if you like, which is basically this, but I usually memorize this one only, so that's like up to you. Use your own GDC of choice, like this one. So obviously, typing is quite time consuming, and there's really no reason for you guys to be watching me type. So if you like, just skip that. My thing is in degree. I need to change it to radian. Okay, let me write down one of these first. So change to radian. Go back to calculation again, and then shift cos answer. Okay, I got the angle to be 0.7508472. When you're working in the steps, you may want to write more than 3 significant figures to make sure that the final answer is accurate. I'll probably write too big, so I'm running out of space, but that is the area of the sector. The radius 15 square minus the area of the triangle, which is half AB sine C, so it's half 15 times 15 sine 0.7508. So I'm sure pretty much none of you would have a problem with this question. Minus 15 square over 2 times sine that. So it's 7.72. Okay. Next, Poisson distribution. Poisson distribution is no longer in AAHL syllabus. Okay. So this is a side graph sort of things. So if you know your stuff, then you should know Q is the amplitude. So what's the amplitude? This is 1, this is 5. Amplitude is measured from the middle, go up to the top. So the amplitude is 2. That means Q is 2. And then R. Well, let's do P first. P is the middle line. It's called the principal axis. Wait, how is that 1? That's minus 1. Then Q is not 2, but 3. Okay. And P is the middle of minus 1 to 5, so that's 2. And then R. So I think you know R would be the original period of the side graph divided by the actual period of your graph, because it's telling you how many times the thing got compressed. So what's the period? If you go from this to this, then the difference between them is minus 3 power of 4 minus negative 9 power of 4. So it's 6 power of 4. So it's 3 power of 2. But this is only half a period, right? Because this is a full period, and you go from the highest point to the lowest point, that's like half of it. So the period is 3 pi. So R must be 2 over 3. The question is, find the area of the shaded region. That is a GDC thing. So you pretty much can integrate obviously you need to find the two x-intercepts, but then again that's a GDC thing. So let me graph it first. So let me type 2 plus 3 sine 2 over 3 through x out over 3. This graph. So I need to find the zeros. Calculate zeros. So this is negative 3.6178 to negative 1.0946. And then most calculator when in the graph can also calculate the area. So this one integral, select a lower bound. I want it to be negative 3.6178. And upper bound, I want it to be negative 1.0946. So I get the area. And of course, an integration would think the area is negative because the area is below the x-axis. And so therefore the area is positive 1.6618. Final term, independence of x. It's not hard. So obviously we do the general term for binomial expansion. Well, technically this is just the general term. Technically there's a summation sign in front for them to equal. But it's usually the general term that's important. N is the power. A is the first term in the binomial. B is the second term. I'm sure all of you know this. Now, except this time we multiply 1 over x cubed in front. So we need a term that is independent of x. It basically means the power inside. We want the term in the expansion that has a power of x to the power of 3, because then it would multiply to this 1 over x to the power of 3 and give a constant term. And that would mean ours should be 7. I think ours is 7. So I usually just plug in one by one and guess. If you really want to, you can use law of indices to calculate it. But I find guessing still like pretty fast. Okay, I need to find 9C7. It's 36 times 1 over, this is to the power of 2. So it's 9x to the power 4. Then negative x to the power of 7 over 2 to the power of 7. So obviously all the x's would cancel out because that's the condition. So 4. The negative was also raised to the power of 7, so it's still a negative. So it's negative 4 over 128. That's negative 1 over 32, I believe. Is that what I want? Yeah, that's just a term. Nice and easy. Okay, random sample of 16 people, I guess. It's taken. Oh, they're so nice. They tell you this is a binomial distribution. That's rare. Normally, you need to realize it is. Oh, it's because they want to ask for when you can use a binomial distribution. Is when the sampling are independent, meaning like each person got picked independently. And also that the success probability is supposed to stay the same. Yeah, so the probability stay the same. I mean, you should say it in more details, but I don't want to write all the words. So, probability that someone in the sample took a holiday in the Lake District in 2019 should remain the same. Find the probability that at least 3 of them, blah, blah, blah. So this is binomial. Number of trials, 16. Success probability, 15%. I want the probability that x is at least 3. So again, that's GDC time. Binomial, number of trials, 16. Success probability, 0.15. I want it to be bigger than or equal to 3. My calculator is cannot do upper bound, lower bound, that kind of things. But it's okay. 1 minus is not too bad. So, what's that? Okay. Well, I should give 3 sig fig, 0.44. Random sample of n, the probability that at least one of them want to be greater than 0.999. Okay. Fine. And okay, so it's like we have a new binomial distribution where the number of trials is n, success probability is still the same. We want the probability of y at least 1, right? Bigger than or equal to 1 to be greater than 0.999. Okay. Now, we don't know n, so we cannot use the binomial distribution function of a GDC. So this one we need to do it ourselves. Okay, what is the probability of y bigger than or equal to 1, right? That's 1 minus the probability that y is 0, right? Because bigger than or equal to 1 would include 1, 2, 3, 4, all the way up to n. So the only value of y you're missing is 0. So you want 1 minus the probability of y to be 0 to be bigger than 0.999. If you rearrange, that means you want the probability of y equal to 0 to be less than 0.001. But what is the probability that y is 0, right? It means of all the trials, they are all failure, okay? You have no success. So it's basically the probability of failure raised to the power of n. 1 minus 0.15. So you want 0.85 to the power of n to be less than 0.01. At this moment, you can draw a graph to find an intersection. You can do n solve, but the answer is also just a log away, 0.001 divided by log 0.85, so it's 42.5. Therefore, the smallest value of n, the question is what's the smallest value of n? It's 43. Next, a mathematical induction problem. This is the differentiation type. Okay, let's do it. I don't think I need a GDC to do this. Okay, for n equal to 1. So left hand side when n equal to 1 is just the first derivative of this. So we'll need product rule. So we copy the first, differentiate the second, differentiate e is just e. And then we chain rule, so times differentiate the inside, differentiate px is p, because p is just a constant. Plus differentiate the first thing, differentiate x is 1, copy the second. What can we do? We could factor out the e to the power of px to the back, and then with xp or px, they're the same, plus 1, and then in front we basically have nothing, but then p to the power of 0 is basically nothing. So this obviously equal to the right hand side when n is 1. So remember the format of mathematical induction, that matters. So therefore the statement is true. The statement is true for n equal to 1. Then assume, use a different color, assume the statement to be true for n equal to k. That is, usually I write out explicitly. That means the kth derivative is assumed to be p to the power of k minus 1, p times x plus k, e to the power of px. Then there is the induction step. So when n equal to k plus 1, we start from the left hand side. We want to find the k plus 1 derivative of this. But the k plus 1th derivative is the derivative of the kth derivative but by assumption the kth derivative is this. Alright, so p k minus 1 pk px plus k times e to the power of px. Right, then we simply have to differentiate this. The p is a constant raised to any power is still a constant, so this is a coefficient, it just stay in front, do nothing. Then we also have two things multiplied together that we want to differentiate, so product rule. So we copy the first, differentiate the second, chain rule, plus differentiate the first, differentiate px is p, differentiate k is 0, copy the second, like that. Similarly, we do factorize. We factor out e to the power of px to the end. We factor out the p to the front. So now we have p to the power of k minus 1 times another p. So that's p to the power of k. Inside we have px plus k plus 1 left. So that obviously is what we want. In case you want to check, it is basically this, except n is now k plus 1. Okay? Therefore, write down the last paragraph to get the last mark. So the statement is true for n equal to k plus 1 if it is also true for n equal to k. Therefore, by the principle of mathematical induction, you copy the question, the nth derivative of that thing, what is it? xe px would equal to that. For all positive integers and okay, we are running late, but two more questions, let's do it. Okay, at a gathering there are 12 teachers, 7 are male, 5 are females, 5 of them are trying to go out. Find the probability, not a probability, find a number of possible ways that there are more male than females. More male than female. Okay. So to have more males, that means of the 5 people, you could have 3 males or 4 males or 5 males. To have 3 males means of that 7 male, you choose 3 of them. And then you need to pick 2 females, so you do 5, choose 2. By the way, this is C, not P, because when you just grow out to get a mu as a group, the order doesn't matter, right? Then plus, you could have 4 males, so it's really similar, 7C4 times 5C1, or you get 5 males. O always plus, okay? I'll save some time and will not punch in to the calculator. 2 of the teachers, I'm guessing I'm supposed to know whether these are male or female names. I'm kind of sure Gary is a male name, but what is this? I mean, guys, I'm from Hong Kong. I'm not a native speaker of English. I mean, I'm sure you can tell from my accent. I mean, this is unfair. Okay, apparently this name is also a male name. And coincidentally, the name Gary actually show up when I search for this. Okay, I'm gonna assume this is a male name. So 2 of the male teachers would not go out. Okay. So, okay, this is pretty interesting. I'm guessing you should pause the video now, give this problem a try if you want. Answer will be coming. 3, 2, 1. So basically, we cannot have both of them. So I'm thinking the easiest way would be making cases. So we can have only Gary or only the other guy because they refuse to go out together, or you can have none of them, so no Gary and no the other guy. Okay, what's the probability of only Gary going? Okay, so now Gary have to go, so Gary have no choice, but he have to go. But in this case, then the other guy can't go. Therefore, we really only have 5 males left. 5 male left. And we also have the other 5 female. All right, so altogether we have 10 people left. And out of that 10 people, we can choose 4 to go. We're choosing only 4 because Gary is predetermined to go, right? So we only need to pick 4 people. Or we have the opposite of the situation. This guy have to go, but then Gary can't go. So still we have 5 males left, 5 female left, and 10. Choose 4 of them to go with him. Or both of them cannot go. But that would mean the same. We have 5 males left, 5 females left, but this time we'll choose 5 of them to go. Right? Because these 2 guys both can go. So that would be the answer. Now, obviously, this is not the only way that you can compute this. So let's make sure you get the same answer as me. So 10C4 is 210, and then tan C5 is 252. So you should get 420 plus 252. So you get 672. Okay. Last question. Okay, a small bean is free to move along a smooth wire with this shape. Find dy dx. Okay. So this is a related rate of change kind of thing. I'm sorry, but I have to say that this paper is rather easy. Okay, unless like there's a really difficult question in paper in section B. Okay, this question 11 could be a bit difficult. Part E look a bit complicated, but still that's only 7 marks. So whole paper of 100 marks. I don't see much question that are difficult, because this question 8 is definitely not difficult for a related rate of change. It's pretty basic. So to differentiate this, we can write it as 10 times 3 minus 2e negative 0.5x to the power of minus 1. Some of you might want to use quotient rule. That's also fine. So 10 is a coefficient, just stay there. When I differentiate, the power drop to the front, and you minus 1 from the power. And then you do chain rule, you differentiate the inside, differentiate 3 is 0, minus 2 is a coefficient, differentiate e is just e. Then chain rule again times differentiate the inside of e, so negative 0.5. So this negative and this negative cancel out, so we still have a negative, so negative 0.5 and 2 would cancel out. So overall we have 10, and over, this thing is to the power of negative 2, so that's over to the power of 2 times this, 10e negative 0.5x. You should get the same even if you use quotient rule. Okay, the only thing I want to mention is, remember when you differentiate the top, differentiate 10 is 0. Okay, so that term would totally be 0. Okay, that's like a common careless mistake. Then find the rate of change of x, dx dt, right? Dt is a, whenever you differentiate with respect to time, it's called rate of change. Find the rate of change of x when x is 4, and that the rate of change of y is negative 0.1. Okay, so we know dy dx. So if you have learned relative rate of change, you know it means dy dt would equal to the derivative of y with respect to x times dx dt. Okay, in case you forgot y, you can imagine you are multiplying the x to the other side. Okay, so dx is gone and got to the right hand side, and then you divide both sides by dt, then you pretty much got the correct expression. And then we just sub in numbers. dy dt is given to be negative 0.1. X is given to be 4. So I'm sure now you see why I thought this question is easy. If you know what to do, it's really straightforward. Then the rest is just calculator. So it's getting a bit late for me over here, so I will skip that. a rather simple section A. I don't think I have demonstrated much, but I still hope this is helpful to some of you, and I'll see you in section B.